Okay, so Physics Unit 3 assignment. So for this activity, the question was we needed to use the conservation of mechanical energy formula in order to solve the amount of thermal energy that's produced during the motion of the object. So what I did was I just did it really simple, built a small ramp, and I took a marble and I let it go, and I waited to see the height that the marble would achieve at ramp number 2, and I compared this to the initial height at ramp number 1, and the difference that was there in the gravitational potential energy, that was what the thermal energy was. Okay, so materials. For this little test experiment, I guess, you're going to need at least minimum of 2 books and try to keep them the same height, tape, cardboard, marble, scissors, and measuring tape. Of course, you'll also need a camera in order to record the actual test and find out the difference in the height. So the process, what you need to do is it's pretty simple in constructing the ramp. What I did was I took a shoebox and I cut it up and I got like 2 pieces that would be used for the ramp, and then a third piece was just like the straight the marble would travel through. For the 2 pieces of the ramp, you need to make sure that they're pretty much the exact same height, and the exact same length. And the reason is because when you set it up, you don't want it to be one size of the ramp to be higher and the other to be shorter or something, because you kind of want to make sure that they're both the same height in order to accurately find out the thermal energy that's produced during the motion of the object. So yeah, then after that, you just fold the ramp and then you could tape it together in the middle. Or you could just take 3 pieces and just tape them together, but I use the former method. So now it's experiment time. Experiment, very simple, just hold the marble, let it go. So for the calculations, so I had an issue I didn't really think about beforehand, and that was finding the mass of this marble. Who knew it was so difficult to do so? So off I went, and I basically tried to use all my skills in grade 7 math, I guess, in order to find the mass of this thing. And with the help of the internet, I tried, first of all, the first thing that I tried was I tried checking online to see if there is a mass, if someone's recording it. And apparently not. The only things that I could find online were the diameters of marbles. And I think the size which I had, it's a pretty small one. Not too small, but it's like not the big ones, and it's not the regular size either. So I kind of deduced that it must be like the 25 milliliter ones. And of course I used the internet again in order to find the density of glass. So marble that I have, I'm pretty sure it's made out of glass, and I just found out the density online. And then here I was trying to figure out like the size of the marble and to check if there was anywhere that the mass was written, and I couldn't find any information on that, so that meant that I had to actually try and calculate it myself. So the thing that I did was I took a tape measure, it's a very bendy one, and I just measured the circumference of the marble, and I think I got 4.5 centimeters. That was like the circumference. After that, I tried to figure out like the volume of the sphere of the marble, and after that, what happened was I just took the circumference formula, c is equal to 2 pi r, and then I found the radius. After that, I input the volume formula, and I found the volume of the of the sphere. Then after that, I finally was able to use the density and the volume in order to find the mass, and I just multiplied these 2 figures together in order to find what the mass of the marble was, and I finally got a figure of 3.78 grams for the mass of the marble. Now, finding the thermal energy that's produced during the motion of the marble. So, in order to do this, it was pretty simple, but there were some fundamentals that are important to note. So, according to the conservation of mechanical energy, energy is neither created nor destroyed, and it's instead converted into other types of energy. For example, in this test, the path of the marble begins at the top of the ramp with gravitational potential energy. And then as it moves down ramp 1 and onto like segment 1, the marble has no gravitational energy, and this gravitational energy is then instead converted into kinetic energy. And as the marble continues to move down the straight, the kinetic energy is then converted into thermal energy, and this is because of the friction that's rubbing onto the surface between the surface and the marble. And what happens is that theoretically, according to how energy should work, the gravitational energy that the marble has at the beginning, at the top of ramp 1, it should be the same as how it should have like at the end of its motion that I'm looking at. So it should be ramp 1, and ramp 2, the marble should go all the way up to the top of ramp 2. As you could see in the experiment, this was not the case. And this is due to the fact that the gravitational potential energy that the marble had at the beginning, although it's the same path, the law of the conservation of energy, it's converted, right? So this thermal energy that's there means that the gravitational energy is not as much as it was to begin with, and it's not lost, it's just changed into thermal energy. And in order to find out what thermal energy was produced in this path, what I did was I took the top of the gravitational potential energy at the beginning of ramp 1, and I found out how I paused the video and I took a recording of the actual experiment, and I kind of figured out and measured how high the marble head went. And the marble at the beginning of ramp 1, it was 16 centimeters, and it only traveled up 7 centimeters up of ramp 2. So the difference in this, what happened was after that, I had to calculate the change in the gravitational potential energy, and after that, this change meant that the result of this change was in fact the thermal energy that was lost. So now I had to input into the, and this formula is simply the kinetic energy at the beginning plus the gravitational potential energy plus the thermal energy is equal to the kinetic energy final plus the gravitational potential energy final. So kinetic energy is 0, and what happens is then we're left with the thermal energy. As I said before, it's simply the change in the gravitational potential energy. And so gravitational potential energy, the formula for this is mgh. And as you can see, the mgh, I took the mg is the same in both scenarios. The only thing that's changing here is the height. So as mentioned before, the heights were different. Height 1 is different from height 2, and this meant that I got a thermal energy of negative 334 joules that has been produced. Alright, so that's the end of the project, activity number 1.